So this video is on properties of parallelograms. So parallelograms are four-sided figures. And again, I have these notes in the homework for you. So you can choose to take these notes on your own paper if you want to, or you can just follow along on the homework and use those notes. So properties of parallelograms. There are several properties of parallelograms. The first one being that opposite sides are congruent. So opposite sides are congruent. And I'm going to be using the symbol for congruent often instead of writing out the word congruent. So just remember that that symbol means congruent. So opposite sides are congruent, and then opposite sides are also parallel. Opposite sides are parallel. That's the symbol for parallel. Opposite angles are congruent. So opposite angles are congruent. Consecutive, and consecutive is also the same as same side interior. So consecutive angles are supplementary, which means they add up to 180 degrees. And then diagonals bisect each other. So the diagonals bisect each other. That's the fifth property. So if we look at number 1, it says each quadrilateral below is a parallelogram. Find the missing measures. We have AB being 15. We have BC measuring 8. And then we have D measuring 68 degrees. So we're going to use what's already given to us to find the missing measures. So one of the properties of parallelograms is that opposite sides are congruent. So if AB is 15, then we also know that DC is 15. So we can go ahead and put this 15 here. If we know BC is 8, then we know that AD is also 8. Now, we know that the measure of angle D is 68, and we also know that consecutive angles are supplementary, which means same side interior angles. So same side, this is the same side, this is the same side. So same side interior angles are supplementary, which means angle D plus angle A has to equal 180. So if you subtract 68 from 180, you're going to see that A is 112. The third property says that opposite angles are congruent, which means angle D is congruent to angle B, and angle C is congruent to angle A. So that means angle B is 68 degrees and angle C is also 112 degrees. Let's try and do number 2. So number 2, we have measurements for JM. We know that one's 29. We know ML is 21. And we know that angle L is 127. So if JM is 29, we also know that KL is 29 because opposite sides are congruent. If ML is 21, then we know JK is 21. If L is 127, L is congruent to J. So that means J is also 127 because opposite angles are congruent. L and K, angle L and angle K are supplementary, which means they have to equal 180 degrees. So if you subtract 127 from 180, you're going to get 53 degrees. And if K is 53 degrees, We know that these two are congruent to each other, so that this should also be 53 degrees. Let's try another problem. So number 3, we have a diagram. We have another parallelogram, but this time we can clearly see that the diagonals are bisecting each other. Of RT is 30. We know that RT is 30. And they gave us that RU is 18. And UV is 7. They also told us that RS is 27. So our first property tells us that opposite sides are congruent. So if RS is 27, then we know that UT is 27. If RU is 18, then we know that ST is 18. Now, if we're trying to figure out VS, we know that UV is 7. These two are congruent. So that means VS is also 7. And if they told us that RT is 30, then we know that these RV and VT need to be congruent. So that means that this is 15 and this is also 15. Let's look at number 4. So number 4, they give us the measure of several different angles. So you need to remember that alternate interior angles are in this picture. And alternate interior angles are always congruent. So they want us to find the measure of angle DEC. So DEC is right here. And they tell us that the measure of angle FED, this at the bottom, FED is 34. So FED is actually this whole entire angle. So if that whole entire angle is 134, but this little bit right here is 71, we need to find how much is the rest, how much is this angle, in order for us to add 71 plus this angle to get 134. So if you do 134 minus 71, you're going to see that it is 63. So this is 63 degrees. The measure of CDE, that is right here, the measure of this angle. So CDE is this whole angle. And I know it's hard to look at, but you can see that this is still a parallelogram. So if you're looking at this four-sided figure, we know that this angle right here plus this angle right here, they need to add up to 180. So if we know that FED is 134, so this is 134, that means that angle plus this angle needs to add up to 180. So if you do 180 minus 134, you're going to get 46. Now we need to find the measure of angle ECD. ECD is right here. Let me erase some of these. Let me erase some of these. I'm going to rewrite that 63. So this is 60. This is 63, 46. And if this, we need to find measure of angle ECD, which is right here. We can see that there are alternate interior angles. This is an alternate interior angle, and alternate interior angles are congruent. So if this is 71 degrees, that means this one is also 71 degrees. And last, the measure of angle DFE. So DFE is right here. This little bitty angle right there. Now this time, we're going to use the property that opposite angles are congruent. Again, this could be a bit hard to see, so I'm going to erase everything on this diagram. I'm going to erase everything here. So we need to find the measure of angle DFE. DFE is right here. But we already know that CDE right here is 46. Now, if you're looking at this in the context of a parallelogram, trying to ignore all of the lines inside of the figure, then you could see that these two angles are actually congruent because opposite angles are congruent in a parallelogram. But we know this little bit is 21. We know this whole thing is 46. So we need to find how much is this angle so that I can add that angle with the 21 to get 46. So if you do 46 minus 21, you'll see that this angle is 25. If you add these together, they give you 46, which means that that's a congruent angle. So the measure of angle DFE is 25 degrees. Let's go to the next problem. So in this next problem, I need to solve for x. And I'm going to use the properties in order to do that. So I have side LM as 9x minus 25, and then side PN as 5x plus 7. So we know that these two sides, based off of the properties, we know that these two sides, opposite sides, are congruent. So we're going to set them equal to each other. So we're going to say that 9x minus 25 is equal to 5x plus 7. 9x minus 25 is equal to 5x plus 7. So now we can move this 5x over, subtract 5x, and we're going to get 4x minus 25 is equal to 7. If we add 25 to both sides, we'll have 4x is equal to 32. Divide by 4, and we get x is equal to 8. Let's try another example. In this example, we have a diagonal. And they told us that TV is 74. So this whole thing is 74. And then WV is 4x plus 1. One thing that we do know is that if this whole thing is 74, these two must be congruent, right? So if you divide 74 by 2, you know this is 37, and this is also 37. So you can set 4x plus 1 equal to 37. Subtract 1 from both sides. You get 4x is 36. Divide by 4, and you get x is equal to 9. Now, if you wanted to try and do it another way, you could also do 2 times 4x plus 1 is equal to 74. You would get 8x plus 2 is equal to 74. Subtract 2 from both sides. You get 8x is equal to 72. Divide by 8, and you're going to get x is 9. Either way, you're still going to get the same answer. So that's 2 ways to solve that problem. Let's go ahead and try to do number 11. Looking at number 11, it says to find the measure of angle B. One thing we know from the list of properties is that opposite angles are congruent. So we're going to set these two equal to each other. 6x minus 15 is equal to 4x plus 11. We can add 15 to both sides. We're going to get 6x is equal to 4x plus 26. We can subtract 4x from both sides. And we're going to get 2x is equal to 26. If we divide by 2, we're going to get x is equal to 13. Now, they didn't ask us for x. They asked us to find the measure of angle B. How are we going to do that? We don't even have an expression for angle B. So the first thing we're going to do is we're going to actually plug it into angle A, because we know that these two angles are supplementary. So if we find angle A, we can subtract that from 180 and we're going to get angle B. So let's plug 13 into this expression. We have 6 times 13 minus 15, and that's going to give us 63. And if we do 180 minus 63, we're going to get 117 for the measure of angle B. Let's do number 13. So this says if the measure of angle KLH is equal to 134, solve for x. So KLH is this whole angle. It's equal to 134. They want us to solve for x. So if this angle is 134, we know that these two angles should add up to 180. So if these two angles should add up to 180, we know that this entire angle, not just this little bit is 25, but that this whole angle is actually 46 degrees. Because 46 plus 134 is going to give us 180. Now, we know that's 46, so let's try and find this other little piece right here. In order to do that, we can simply do 46 minus 25, and we know that this is 21 degrees, because 21 and 25 is going to give us 46. 21 and this angle right here, angle K, they are alternate interior angles, and alternate interior angles are congruent. So if alternate interior angles are congruent, then we're going to set 4x plus 9 equal to 21. Subtract 9 from both sides, and we're going to have 4x is equal to 12, which means x is equal to 3. So now we're moving on to proving parallelograms in the coordinate plane. So if we're trying to prove that a figure is actually a parallelogram, there are 3 methods that we can use. Again, this is in your notes, but feel free to jot these down on your own sheet of paper. So if we're trying to prove that a figure is a parallelogram, we can prove that both pairs of opposite sides are congruent. So we can say that if AB is congruent to CD and AD is congruent to BC, then ABCD is a parallelogram. So if AB is congruent to CD and AD is congruent to BC, then we know we have a parallelogram. And in order to prove that, we can use the distance formula. The second method is to prove that both pairs of the opposite sides are parallel. In order to do that, we are going to use the slope formula. And if you remember, parallel lines have the same slope. So if we use the slope formula, we'll show that AB is parallel to CD, and we can show that AD is parallel to BC. So AB is parallel to CD and AD is parallel to BC using the slope formula. The third method is to use both the distance and the slope formulas. So if AB is congruent to CD and AB is also parallel to CD, then we can say that ABCD is a parallelogram. So we're going to use these 3 methods to prove that these figures are parallelograms. Let's try number 1. So it says to determine whether the figure is a parallelogram using the distance formula. So we're going to use the distance formula. If you don't remember the distance formula, it is d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So the first thing I'm going to do is I'm going to label my points. x1, y1, x2, y2. And the same thing here. x1, y1, x2, y2. So first we're going to check AB. Remember, we need to check all 4 sides. So we're actually going to use the distance formula 4 times. So for side AB, our x sub 2 is 1 minus negative 7 squared plus 2 minus 4 squared. And that is equal to 1 minus a negative. This turns into a positive. So you're going to have 8 squared. And we know that 8 squared is 64. 2 minus 4, you're going to have negative 2. And negative 2 squared is 4. 64 plus 4, that's going to give us the square root of 68. Let's check side CD. So if we're doing CD, my x2 is 1 minus 9 squared plus negative 6 minus a negative 8 squared. Minus a negative turns to positive. You got 2 here. 1 minus 9 is negative 8. Negative 8 squared is still 64. 2 squared is 4. So we have the square root of 68. AD. Let's check that. So I'm going to actually have 1 minus negative 7, again, squared, plus negative 6 minus 4 squared. Minus a negative, that's going to turn to a positive. You're going to have 8 squared. And then negative 6 minus 4, that is negative 10. So we're going to have 64 plus 100. And that's going to give us the square root of 164. Last side that we have to check is BC. All right, BC, we're going to have 9 minus 1 squared plus negative 8 minus 2 squared. And that's going to give us 64, because 9 minus 1 is 8. 8 squared is 64. Negative 8 minus 2, that's still negative 10. Negative 10 squared is 100. So we're going to have the square root of 164. If you notice, this is the same as this. These are the same. They're congruent. And these are the same. So we can say that yes, ABCD is a parallelogram because AB is congruent to CD and AD is congruent to BC. We use the distance formula and we proved that both pairs of opposite sides are congruent. If we look at this second example, I'm not going to do this example in full, but if you look in your notes on the homework, you will see that when you do this problem and you use the distance formula, you're going to get PQ is going to be equal to 104, the square root of 104, and RS is going to be equal to the square root of 82. This is not a parallelogram because those two sides are not congruent. If these two sides were congruent, then you could say they're a parallelogram. Let's look at example 3. So this third one asks us to determine whether the figure is a parallelogram using the slope formula. So if you don't remember, the slope formula is m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And we need to check all four sides. So I'm going to label x1, y1, x2, y2. And I'm going to use my slope formula to find the slope of wx. So y2 is -6 minus a -4 over 1 minus a -7. Minus a negative turns to a positive. -6 plus 4 is -2. Minus a negative turns to a positive. 1 plus 7 is 8. Reduce that, we get -1 over 4. Let's do it for yz. We have x1, y1, x2, y2. Y sub 2, -12 minus a -13. And then we have 1 minus 5. Minus a negative turns to a positive. -12 plus 13, we're going to get a positive 1. 1 minus 5 is going to give us a -4. So we still have -1 over 4. Now we're going to do WZ. So W and Z. My Y2, I'm going to have -12 minus a -4 over 1 minus a -7. Minus a negative turns to a positive. -12 plus 4 is -8. Then we're going to have minus a negative turns to a positive. 1 plus 7 is 8. -8 over 8 is -1. Last one we need to check is XY. So that is these two, X and Y. I'm going to call this my X1, Y1, X2, Y2. So I'm going to have -13 minus -6 over 5 minus 1. Minus a negative turns to a positive. -13 plus 6, that's going to give us a -7. 5 minus 1 is going to give us 4. If you notice, these are not all the same, so it's not going to be a parallelogram. We have one pair of congruent sides, but the other side, the slope is not the same. So, no, this is not a parallelogram. If we check this one, I'm not, if we check this one, number 4, we're going to do the same thing. We're going to label our points. I'm going to use the distance formula. M equals y2 minus y1 over x2 minus x1. I'm going to label x1, y1, x2, y2, x1, y1, x2, y2. And we're going to start with EF. So at the top, I'm going to have 10 minus 8 over 6 minus 0. That's going to give me 2 over 6. I'm going to reduce and I'm going to get 1 over 3. Next, we have GH. I'm going to have -2 minus 0 over -4 minus 2. I'm going to have -2 over -6. Remember, negative over a negative turns to a positive 2 over 6. Now reduce it and you get 1 over 3. EH. So that's E and H. We're going to have -2 minus 8 over -4 minus 0. So we're going to have -10 over -4. Reduce that. And we're going to get -5 over -2. But negative over negative turns to a positive. So it's positive 5 over 2. Last one we have is FG. So that's F and G right here. We're going to have 0 minus 10 over 2 minus 6. That's going to give us a -10 over a -4. Negative over a negative turns to a positive 10 over 4. reduce, and you get 5/2. If you notice, these two are the same. They're congruent. These two are the same. So we know that, yes, this is a parallelogram. That's all, folks. Until next time.